All right, so looking at adding fractions with unlike denominators, our first problem is going to be 1/2 plus 1/4. All right, now you can't just add these fractions without changing the denominators. And an example of that, this is an example I used in the last class as well. What is 1 adult plus 3 adults? 4 adults. And everybody looks at me like I'm crazy when I ask that question. What is 2 children plus 3 children? 5 children. What is 2 adults plus 2 children?
4
2 adults.
2 adults. 1 half.
What is 2 adults plus 2 children?
2 children. 2 and a half.
What? 4 what? People. Why can't you do 2 adults and 2 children? Cornelius. Okay, doesn't know how to explain it. Julia? There are 2 different types, aren't they? You have adults and you have children. But they're labeled completely different. Yeah, they're humans, or yeah, they're people. And that's what Kira said. She said, well, 2 adults plus 2 children is 4 people. She gave them a completely different name, a completely different category. So what we're doing today is we have to find that category that fits these fractions. Okay, you cannot just add 1/2 plus 1/4 without finding a common denominator. Have to find a common denominator. So in this case, one of the easiest ways to find a common denominator, and again, this is different from what I showed my homeroom, so you guys are going to get the way that your parents learned how to make common denominators. You can multiply each fraction by the other denominator. So in this case, this 1/2, I'm going to multiply the 2 by 4, because that's what the other denominator is. And then whatever I do to this denominator, I have to do to the numerator. Oh, and then, losing my mind, times 4, there we go. So 2 times 4 is what?
8.
And 1 times 4 is what?
4.
So 1/2 is equivalent to 4/8. And then 1/4 I'm going to multiply by the other denominator of 2. So I multiply the denominator by 2. I need to multiply the numerator by 2. 1 times 2 is? 4 times 2 is?
8.
So then 1/4 is equivalent to 2/8. Before we add it, I'm going to show you why it works that way. Okay, this is what the other class did. So now I'm just going to kind of show you why it works the way that it does. 1/2, let's model 1/2. Here's my half. So I take it and I shade in 1 part. Alright, we're going to model 1/4. I'm going to use it a different direction. So I did horizontal, a horizontal line. Now I'm going to do vertical lines. 1, 2, 3. So I end up with 4 sections. And I'm going to shade in 1 section. So this is 1/4. All right, now to do the common denominator, what does common mean? What does common mean? 80.
You see a lot and it's alike.
Okay, something you might see a lot, but in this term, or in this case, I want to use that word alike. Okay, so common means same. So I want to do the same thing to this half box that I did to the 1/4 box. What did I do to the 1/4 box? Did you read it? Okay, but what did I do before I shaded anything in? I drew how many columns? 4 columns. So 1, 2, 3. Now I have 4 columns. So I'm multiplying by 4, and there I get 4 eighths. Do y'all see that connection here? So there's my 4 eighths. All right, now to the 1/4 box, I want to do what I originally did to the half box, which was what? Talia? I drew one horizontal line, which gives me how many rows? 2 rows. So 1 times 2 is 2, and 4 times 2 is 8. And there's my 2 eighths. Okay, do y'all see the connection? Okay, that's why it works to just multiply the fractions times the opposite denominator. So if I'm looking at it, we have 4 eighths plus 2 eighths. And all you have to do, since our denominators are the same, is to add your numerator. So what's 4 plus 2?
6.
6. So we have 6 eighths. Now, with fractions, we need to always simplify if we can. And to simplify means to get that fraction smaller. We want to reduce it. Is there a number that I can divide both 6 and 8 by and get an even number, meaning no remainder? And it has to be the same number. So whatever I divide by the numerator, I have to be able to divide the denominator by it, and it has to give me an even number, meaning no remainder. What could that be? Maitland? 2. So if I divide 6 by 2, I get what?
3.
And if I divide 8 by 2, I get what?
4.
So then 3/4 is my answer. Same. We'll get to that maybe tomorrow. Okay? Mia. Yes. What? You don't get what? It's Alright, any other questions on this one? No questions. Okay. Let's look at another problem then. All right, let's look at 1/3 plus 1/2. All right, what are my two denominators?
3 and 2.
3 and 2. So I want to multiply this 1/3 times what?
2.
Times 2. And so 3 times 2 is what?
6.
And 1 times 2 is?
2.
So 1/3 is equivalent to what?
2 6.
All right, what can I multiply half by?
3.
Okay. So whatever I do to my denominator, I have to do to my numerator. 2 times 3 is what?
6.
And 1 times 3 is?
3.
So then half is equivalent to what?
2 6. No. 3 6.
3 6. So now we can just add our numerators. 2 plus 3 is what?
6. 5.
Think about what we're saying, and then our denominator is going to stay the same. Is there a number, the same number, that can go into both 5 and 6 evenly? Alright. Somebody just said, Jabria just said 1. Can 1 go into 5 evenly?
Yes.
Can 1 go into 6 evenly?
Yes.
But will it change the fraction?
No.
No. So you never, ever, 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 ever divide by 1 because it wouldn't change the fraction. 5 divided by 1, 6 divided by 1, it's 5 6. Alright? So let's think about it. 6 can be divided by 2. Can 5 be divided by 2 and get an even answer?
No.
No. Alright, 6 can be divided by 3. Can 5 be divided by 3 and get an even answer?
No.
No. 5 can be divided by 5. Can 6 be divided by 5 and get an even answer?
No.
No. So then this is already simplified. That's right. 5 6. If the answer you would get is even. Alright? I did this little mini lesson in the other class. I'll do it for you guys too. It doesn't matter if both the numerator and the denominator are even. So let's take a look. Let's say 3, no, that wouldn't work. Hold on. Let's do 3 twelfths. Alright? You have an odd number for 3. You have an even number of 12. But both of them can be divided by 3. 3 divided by 3 is?
1.
And 12 divided by 3 is?
4.
So that's simplified. Alright, if you had 10 15ths, what can both the 10 and the 15 be divided by?
5.
Both by 5. So 10 divided by 5 is? 2. And 15 divided by 5 is?
3.
3. Alright? But now, of course, if I have two even numbers, that can definitely be simplified. So 4 divided by 4, 8 divided by 4. 4 divided by 4 is?
1.
8 divided by 4 is?
2.
But it just has to be divided by the same number and get an even answer. Brian?
For the first one, I noticed like we were just dividing the top one. The same thing with the other one, but when you got down to 10 times, we like got rid of that one, so we could like divided by that 5.
Coincidental. It's just coincidental. It won't always happen that way. Yes, ma'am.
Can you divide by double digits?
Yes, so the question was, can you divide by double digits? Well, if your fractions can be divided by those double digits. You know, if you had 10 20ths, let's say. So, yeah, you would divide by 10 for both of them, and you'd end up with 1/2. If you did 22 over 44, what can you divide by?
11. 22. Oh, yeah, 11.
Right. So yeah, it just depends on what the fraction is. Most of our fractions though, especially for right now, you're going to be dealing with single digit divisors. Alright, so let's go back to one more problem. Does anybody have a question on 1/3 plus 1/2? how we solve it. There. This is working it out. It needs to be worked out either with this or with models. Okay, but yeah, I always need to see some type of work with it. I need to see what you did to get to the answer. All right, so let's look at another problem. 2/3 plus 1/4. All right, using the same method that we've just done for the previous two. What are my two denominators?
3 and 4.
3 and 4. So for the 2/3, what am I going to multiply both the numerator and the denominator by? Emma?
4.
4. So 3 times 4 is what?
12.
And 2 times 4 is what? I've only got like 2 kids in this classroom right now. All right, let's look at the 1/4. What am I going to multiply both the denominator and the numerator by here?
3.
By 3. Oh, everybody came back. 4 times 3 is what? 4 times 3. All right. And 1 times 3 is?
3.
So then 1/4 is equivalent to 3/12. All right, Ethan. 8/12 plus 3/12 is what? 11/12. Is there a number that can go into both 11 and 12 evenly? Mia. All right, 3 can go into 12. 5? 5, 10, 15, 20, 25, 30, 35, 40. Okay, definitely not 5. All right, 2. 11 divided by 2 is what? 3. 11 divided by 3 is what?
6.
11 divided by 3. Can't do it. Okay, look at your multiples. 3 times 1 is what?
3.
3 times 2.
6.
3 times 3.
9.
Okay, we need to, let's think about our facts. 3 times 3 is what?
9.
3 times 4.
12.
Did I ever say 11?
No.
So it's not divisible by 3. Mayor. It cannot be simplified. 11/12 is as simplified as it can go. It is already simplified. Okay, but you are always going to hear me ask, is there a number that can go into both of them? Whether it can be or not. You need to think. You need to make sure you think and analyze every problem. All right, we're going to do one more before we move on to our problem set. See, Addie, I thought you were raising your hand again. All right, 2/5 plus 2/3. Cornelius, what are my two denominators?
5 and 3.
5 and 3. What am I going to multiply my 2/3 by, Jake? Or my 2/5 by?
1.
Not 1. I'm going to multiply it by the other denominator. What's the other denominator? 3. So 5 times 3 and 2 times 3, and 5 times 3 is what, Jake? 15. And 2 times 3 is what? All right, for 2/3, Jabria, what am I going to multiply? I'm going to multiply them both by 5. So Jabria, 3 times 5 is 15. And 2 times 5 is 10. So then my new fractions, 2/5 is equivalent to 6/15. And 2/3 is equivalent to 10/15.
16.
All right, go ahead, Jabria. 6/15 plus 10/15 is what? 16/15. Ooh, hands up. Why are our hands shooting up? Aiden.
And that's an uneven fraction.
It's an improper fraction. This is improper, meaning that our numerator is bigger than our denominator.
You can't do that.
Can. It's just not normal. Alright? I want everybody, I want you to think back to lesson 2, where you had a sum and you had to come up with two fractions or a whole number and a fraction that equaled that sum. Alright, let me rephrase. What is a whole number fraction with a denominator of 15? She said. Talia. What was it? So 15/15 is equal to what? One whole. So 15/15 plus what gives me 16/15? Mayar. So then our whole number is 1 and our fraction is 1/15. Huh? 1 and 1/15. It's really not. It's just helping you to see how you got it. Okay? This 16/15, and so another way that you can kind of look at it is if you wanted to break it apart, you could say it's made up of 15/15 plus 1/15, and that 15/15 is equal to 1 whole. So you have 1 whole and 1/15. All right. I want to do a mini lesson. Let's do this.
Yes.
All right. 19/6.
Yes.
All right. We know that our denominators need to be 6. I want one of them to be a whole number of fractions.
Wait. What? What? Oh, I see.
All right. Let's see. I've got some hands shooting up, so let's see. Maitland.
3/16.
Okay, but let's do the fraction part first. What would the numerator be?
It would be 6. I don't understand this part.
Just listen.
It would be 18/6.
All right, so that 18/6, 18 divided by 6 is what?
3.
Remember, a fraction is also showing division. So 18 divided by 6. And guys, you can look at it just like this. We're going to do a shortcut. Let's do... Alright, everybody look up here. 21 divided by 4. 21 divided by 4. 4 can go into 21. How many times?
5. The remainder of 1. The remainder of 1.
5 times 4 is 20. This 5 is your whole number.
And 1
The 1 is your numerator.
Oh, it's a 4.
4 is your denominator.
It's 5. So do we just do this part, not the other part?
What other part? That part? The first part?
No.
No. I'm showing you multiple methods, guys. I always show you multiple methods.
I like the second part better.
Fine. Do the second part. This is how your parents were taught.
Really? Oh, I like it that way. I'm gonna feel like so old. This is nothing. I'm gonna feel old then.
That was Emma Kate, who just said that her mother is old.
It was still recording?
Okay. Alright, one last problem, guys. Listen up. 2/7 plus 2/3.
3. We should have told ourselves.
Alright, Tourette's, hold on. Okay. Brian, what are my two denominators? 7 and 3. So my 2/7. Cornelius, what am I going to multiply the 7 and the 2 by?
3.
By 3, very good. So 7 times 3 is what?
21.
2 times 3 is what?
6.
So then 2/7 is equivalent to 6 over 21. Ethan, what am I going to multiply the 2 and the 3 by? By 7. Given the opposite denominators. Okay. So 3 times 7 is what, Ethan? 21. 2 times 7 is? 14. So then 2/3 is equivalent to 14 over 21. Alright, 6 plus 14 is what, Zane?
20.
20. Our denominator stays the same. Is there a number that can go into both 20 and 21 evenly?
4.
4 times what will get you 21?
3.
4 times 5 is 20.
4.
3 times what will get you 20?
Wait, no, it's 4 times 5. 4. 4. 20. 4.
Mayor, 5 times what will get you 21? Ethan,
It's too late.
it's already simplified.
I can say that the word out. Can we do one more? No. Are we the teacher? No.
Yeah, I like excitement, but yes, you be quiet. Face front. Alright. Does anybody have any question about what we just did? No questions. Okay. Alright, so we're going to stop with